Hello guys, so in this video we'll be talking about our next topic, which is arrays in Java. So let's understand what actually arrays mean before going into the programming part. So to visualize what arrays look like within programming, let me give you a brief example. Think of arrays like set of containers, set of joined containers together. Okay, set of joined containers. Say for example, you have a container, you have a set of containers, that are connected together. Do you see? That are connected together. Okay, and they have cold drinks like the soft beverages, right? You have the thumbs up, you have Coke, you have Mountain Dew, you have Fanta. So they are basically a set of containers, nothing more than that. So like this is the simplest definition of what arrays are, okay, and what they look like basically. So again, as you can see, this is another set of containers, this is a different set of containers. Okay, again, they are connected with each other, and you have these chocolates, you have Cadbury, you have this dark chocolate, this Kit Kat, and there's this another chocolate, right? Then you can see there is another set of containers which are again joined together, and these containers are having cookies within it. This is bourbon, this is Jim Jam, Oreo, and yeah. So that's basically what arrays are. Okay, now two things to remember before we start jumping into coding. First thing is that, oh, I guess there is some issue with this. Let me put this back over here. Okay, over here you can see they are homogeneous. Homogeneous means they cannot have multiple types of things into one set of container, right? So what I mean is that if you see these green set of containers, they only have the beverages, right? They only have the beverages, the soft drinks. They don't have any cookies or chocolates. Similarly, if you talk about this set of containers, right, you can only see chocolates, no cookies or cold drinks over here. So again, if you talk about this one, you can see just the cookies. Okay, so you can see the type is same. Yes, of course, this is a different beverage, and this is a different beverage, but the point is they all are beverages, they all are chocolates, they all are cookies. So only one type is allowed. You cannot have a set of containers that are joined together and you can keep beverages and chocolates and cookies within the same thing. That's not really allowed in Java. Not just Java, if you talk about arrays in general, if I'm talking about arrays are homogeneous, they are not heterogeneous, right? You understand by homogeneous, right? It means like same type. You cannot have beverage and the chocolate and cookies within the same set of containers. That is not allowed. The second thing that you have to keep in mind is that arrays are of fixed size. Okay, this set of containers that you see over here, you cannot add an extra container over here, you cannot add an extra container over here, you cannot do that, or you can't even add an extra container in between these joints, right? You cannot do that. So once a set of containers is created, it is created. You cannot add it from behind, you cannot add it to the front, you cannot add in between anywhere, you cannot change the size. Okay, so two things: the size is fixed. Once you create an array, the size is fixed. There is absolutely no way you can change the size of an array. You cannot do that. The second thing is that they are homogeneous. You cannot put integers and float and string into all into one set of containers, that is not into a single array. Okay, you can only have either beverage, you have to have all of them into a same type. All of them must be chocolate, all of them must be cookies. You cannot mix them. So that's two things about arrays. So before we go any further, let's see how we define an array. Okay, I won't be using Blue for this lecture because that's not really needed at this moment. But anyway, I'll quickly open J shell and show you. So if I open J shell, yeah. Okay, let's see how to define an array. let's see how to define an array. So say for example, if I am trying to define a set of containers, if I am trying to define, let me draw it out so that you can visualize. So what I'm trying to do over here is that, let's say I'm trying to draw a container, a set of container that are joined together, of course, and they must have integers only. They all are, I mean, all the values within this container has to be an integer, and let's say we need a size of 3. As I have already told you, the size is fixed, you cannot change the size, so you have to keep that in mind before creating the array. Okay, and again it is homogeneous only, you cannot put string or float value into these things. Okay, so let's see how do we create. So the syntax is basically like this. Syntax is define the array is like this. So you want to define an integer array, so write int whatever the type that is. Okay, let me just write the general syntax. So the general syntax for this would be the data type, whatever the data type is, the variable name, okay, and most importantly, when you are trying to define an array, is you have to put square brackets. Okay, you have to put square brackets like this. Okay, that's how you do it. That's how you define an array. Okay, but just defining is not enough, you have to initialize an array as well. So to initialize, either there are two steps, either you do it like this, you can I'll show you the direct step actually. So you can say equals to, now you say new whatever the data type is, and very importantly, you have to type in the size. Over if I want a set of container of 3, a set of containers that are having 3 containers joined together, I have to write the size over here, So this is the general format. Okay, so if I want to create an integer array with size 3, I would simply say, what is the data type? Int, then the variable name, say I'm giving it arr for array, and I am putting empty square brackets, and now I'll be saying just new, and now I'll be saying int, and what is the size that we want? 3. Just put it like this, and you will have an array, you'll have an integer array of size 3. That's how you define and initialize an array. And initially, of course, when you define an integer array of size 3, by default they will be 0 0 0, and it will look like this only. This is how an array looks like, and I'll show you quickly. Let's go back again. Let's define an integer array. So int arr square brackets new int 3. So I have an array of size 3. How does it look? This is how it looks. See, 3 zeros, because initially when you say I need an integer array, it basically creates a set of containers having 3 containers, and every container is having 0 as a value. Okay, 0 as a value. So that's how array works. So we can store, can we store different values within it? What is the use of it? Yes, of course we can do that. Let's go back again. How do we access such values? Say for example, I'm just saying say I have an array. Say the array is 36, 24, 98, 65 and 12. Okay, I have this array. So now if I want to get this value, what do you say, what is the location of this value? Now if you're just a regular guy, you will say this is 1, this is 2, this is 3, this is 4, this is 5. So yeah, this is in 4th position. You are wrong. Okay, in computer science and in Java, we usually start counting arrays from 0, not from 1. So this will not be 1 2 3 4 5. Yes, the length will be 5. Okay, the length will be 5, of course. The length is basically what is the maximum of, like, what are the maximum number of containers within this set of container. So length is 5, no doubt in that, but the point is the counting starts from 0 onwards. So this is in not in first position, this is in 0th position, this is in first position, this is second position, this is third, and this is fourth. And technically it's not it, although I'm saying position, it is not position, rather these are called index. So when I say, I will talk like this, what's there in zero in the second index? Second index means this one. What's there in the fourth index? Fourth index means this one. So it is called index. Okay, not position. Position is simply, this term doesn't exist in arrays in terms of arrays. What is the length of this array? The number of containers. How many containers are there? 1, 2, 3, 4 and 5. So 5 is the length of the length of the array. That's okay, but the counting will always start from 0. So say, for example, if I want to get 24, what would I do? What is the index? Index is 1. So I will simply write ARR. I need 1. I need the first index. That's how the computer will understand. Okay, what is there in the first index? First index 24. So I will get 24. Now I'll show you in action what does that mean. So there is another way. There is another way to define an array. Like, the thing is that either you can define in this way, or if you directly define it, you can define it like this also. Let me show you. Go ahead and simply say int, again I'm doing the same thing, ARR equals to, now look at this, I am not writing new or something. Like, if I do this, I will get an array like this. If I do this, I will get an array which has 3 containers and everything will be initialized to 0 if I do this. But instead what I can do is directly write the values over here. I can directly write 36, 24 and 12, and I can write as many as I want to, and that will be the size basically. I am directly defining the values over here, 4, 26, something like this. So now I can directly do this. Yes, absolutely. What are the indexes? 0, so 0th index, first index, second index, third index, fourth index, fifth index. What is the length? Length is 1, 2, 3, 4, 5, 6. So it will be length of 6. Okay, so length would be 6. Maximum index would be 5. Maximum index is nothing but length minus 1. That is how you get the maximum index. Okay, so let's see how we can fetch values from it. So I can see what will happen if I simply go and say system out dot println, and if I simply say ARR 4, what would I get? What will be printing out? So it will check the 4th index of ARR. What is the 4th index of ARR? 0, 1, 2, 3, 4. So I would get this value. Oh, it's a coincidence, even the value is 4 itself. So I will get this only. So that's how you can print it. You can access things. You can access things like this. Let's show you an example of this quickly. Let's go back. Okay, this is one way. Okay, this is, now if I try to access all these values, we have ARR, right? So what is ARR 0? What is the 0th index? It is 0. What is the first index? It is 0. What is the second index? It is also 0. Why? Because all of them are 0 when you initialize it. Like this, if you initialize, it will all be 0. Okay, but the another way of initializing arrays are like this, ARR like this, and we can directly say 12, 56, 47, 92, 13, 90, 43, 9, 3, 5, something like this. This is a big of an array, right? Okay, this is now, as you can see over here, if you can see over here, I did not mention the length. Like here I mentioned the length and it created the length, but here I just have to write the values, and it will automatically see that okay, this is the length. So it will automatically calculate how 1 2 3 4 5 6 7 8 9 and 10. So now it will understand, okay, I need an array of length 10 which are having these values. Okay, it's that pretty simple. Here I have to explicitly define that hey, it's an array of 3 integers, but here I am not defining the length, rather I am writing the values directly, and it is counting. Okay, 1 2 3 4 5 6 7 8 9 10. So it understands it has to create an array of length 10 which are having these values. So that's how it works. Now say for example, if I do a system.out.println and I say ARR, I don't know, I'm just typing CERN. So what do you think you will get? Pause the video and try to come up with an answer. Okay, all right. So it's the 7th index of array. 7th index means 0, 1, 2, 3, 4, 5, 6, 7th. This is the 7th index. So we should get 9. We should get 9. If I hit enter, as you can see, you are getting a 9. You are getting a 9. So that is expected. If I try to do maybe 3, what would I get? Again, try to come up with your own answer. 0, 1, 2, 3. So I will get 92. As you can see, that's how indexing works. So it starts counting from 0 only. If I say 0, I will get what? 0th index of array. 0th index of array is 0. This one. This is the value. So it will go and check, okay, what is there inside the 0th index of this array. So it will get 12. So like that's how it works basically. Okay, cool, absolutely amazing. So yeah, my next point is, can you change these values? Can you change these values? Can you go in and say, so let's go back to the board once. Let's say you have this. Let me just quickly delete all these things. Okay, all right. So say you have this array, and you all of a sudden you say ARR 3 is equals to 200. What will happen now? What will actually happen is that it will try to find the 3rd index of this array, which is 0, 1, 2, 3, which is this one, and it will set 200 over there. So that means 15 will be gone, and in place of 15 there will be 200. Did you understand? Similarly, if I try to do something like this, if I say ARR 0 is equals to 600, what will happen now? It will try to find the 0th index of ARR, which is this one, which means, and it will set it to 600, which means this will go and 0th index will be 600. Okay, that's how this works basically. So if I try to do this, let's go back again. I have this big huge array. Okay, let's try doing this. ARR, say I want to replace this 13 with 1300 or maybe 1800. If I want to do this, what would I do? I have to find the index first. 0, 1, 2, 3, 4. So this is the 4th index. So I would say ARR 4 is equals to 1800, something like that. And now if you try to see ARR, if you try to print the array or see the array would be, as you can see, we have changed the 4th index. So 0, 1, 2, 3, 4. As you can see, the 4th index was previously 0, 1, 2, 3, 4, 13. But now after changing it, it has become to now what? 1800. What is expected? So we can change the values like that. We can say ARR 0 is equals to 5000. You know what will happen if I now try to see what is there inside ARR? It will look like this, 5000, because we have changed the first value. So how do you get the first and the last value? Very simple. First value is, of course, obviously it's going to be 0, right? You can simply say ARR 0. This is what? First value. Okay. Okay, how to get the last value? Well, two ways. Either you count what is the maximum, like what is the last index. So that is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9th. 9th index is the last index. So either you type it like this, 9. You will get the last value, of course, because this is in the last index. Or there is an alternative way. See, arrays do have an attribute called length. So this is your ARR, right? If I want to see what is the length of ARR, I can simply say ARR dot length. This is an attribute. This is not, okay, this is not a method. You don't do this, okay? Just this, no brackets. This is an attribute. As you can see, what is the length? Length is 10. Length is 10, correct? So if I want to get to the last value, I need to do -1, right? This is the length 10. So of course the last index would be what? 9. So what do? I simply subtract 1. So I can simply say ARR dot length -1. Simply I get 5. That's how you do it. ARR length -1. So ARR length is 10, of course, like you can see over here, and I subtract 1, gives you index 9. So 10 minus 1, 9. What is the 9th index? This is the 9th index. You can check it out and it will give you 5. So that's how you can access values, and you can again change the values as well if you really want to change. This is how you change the values within an array. But again, like I said, okay, what about this? This is our array, right? This is our current array. So array has a length of 10. So what is the maximum index? Of course, a length -1, which is 9. But what happens if I try to do something like this? ARR 1000, or maybe say maybe 300, which doesn't even exist because the length finishes here only. It only has 10th elements, and the last index is, of course, 9th, right? So if I try to do array 300 is equals to maybe 1000, if I try to do this, what will I get? I will get an error. Why? It will simply say, if I again do it, yeah, it will simply say index 300 is out of bounds for length 10 array. I mean, the length itself is 10. How can you go to index 300? It doesn't even exist. So it will give me an error if I try to set something. What about reading something? Will it give me error then also? Println and tries 200 maybe. What would I get? Oopsie. Again, I'll get the same error. It will say, how can you go to 200? The length is 10. The maximum number of items in this array is 10. How can you go to 200? It doesn't even exist. So it will give you an error, an exception basically, that array index out of bounds exception. You will get this error. If you try to access or modify anything that doesn't even exist, you will get this error. In C, the behavior is actually different. You will get some garbage value, but in Java, it's different. It will simply give you an error rather. So that's how the concept of arrays work. And yes, another way to define the same thing is this, like you can do this in a two-step process. Like for example, what I'm saying is this. What I'm trying to do this, either you can do this int ARR, and then you can simply say new int, new int 5, type in the line, and you will basically get a array of 0 0 0 0 0 5 5. I said 5, right? So see, yeah, you will either you do this, or there is another way. Either you do this in the first line, and then you say ARR is equals to or simply ARR equals to new int 5. So doing the same thing, first I am defining this, then I am initializing this. But again, why would you do this? Why would you do this? You can do this, yes, but why would you do this? It's a single line, just do it single line now. So there is actually no way, I mean actually no point of doing this, but yeah, it is, again, it's possible. Java gives you a lot of way of doing the same things. So anyway,
All right. Now that we have a basic understanding of what arrays are and how to access elements of arrays in a basic way, let's look at the formal definition. What does the formal definition says? So I have taken this screenshot from Wikipedia. Um, let's go through it slowly. Okay. So this says an array is a data structure. What is a data structure? Well, for simplicity, it's a structure that holds data. So an array is a data structure consisting of a collection of elements. Okay. So array is basically a collection of elements. Okay. Now, the important thing to look here is of same memory size. Okay. It has to be of same memory size, each identified by array index. Okay. You know what array index is, right? The position of the elements in an array. So let me again reiterate. An array is a data structure consisting of collection of elements of same memory size. This is very important. I already said that arrays are homogeneous. So that means you can only insert an integer value into an integer array. You cannot insert some other data type into that array, right? And of course, if everything is integer, of course every element will have the same size, at least in Java. So integer is having 4 bytes. So every element will be of 4 bytes. So that satisfies this condition. Every element has to be of same memory size. Cool. Each has to be identified by array index. So that is the position of elements in an array. An array is a mutable. What is mutable? It means editable. Like I already said that if you take some index, say for example, if let's say x is equals to 1 2 3 4 5, okay, or let's take a better example. Say x equals to 100 700 300 and 200. So same memory size. Okay, so each of them are integers, right? So this is 4 byte, this is also 4 byte, this is also 4 byte, this is also 4 byte. Everything is an integer. Nice. Everything has to be identified by at least one array index. What are indexes? 0 1 2 3. These are the positions. Okay. Now what is this term? What is mutable mean? What does mutable mean? So say for example I say x2 equals to 9000. What will happen in Java? So x2 refers to this element and I am saying x2 is now 9000. So this 300 will be gone and in place of this 300 you will have 9000 over here. So this is what mutable means. Mutable basically means something that is editable. Okay, so mutable means you can change. Okay, you can change things. So that means that mutable is just a fancy term for things which you can change. So you can change the value, right? So an array is a mutable data structure. And linear collection. Now this is again important. I'll come back to this point. Okay, I'll come back to this point. So for now, it is a mutable and linear collection. It is linear because it's going in one stream. Think of it like this. I'll go into a little bit more detail in some time. And now important part is with the same data type. Okay, so you are seeing that this is an integer array, right? So every integer, so every element is basically an integer. So it satisfies that condition as well. Computed from its index tuple by a mathematical formula. I'll come to that as well. So let me give you directly what actually is happening when you are declaring and creating an array inside Java. So say you have this array x and you are having these 4 elements 37 52 76 and 81. What exactly is happening? So everything, every variable, every array, every data structure, whatever you are creating inside the Java program or whatever program for that matter, it doesn't matter if it is a Java program or a Python program, everything is getting stored inside RAM. Okay, every variable, every array that you're creating is getting stored inside the RAM. Now inside the RAM is a big place. Okay, RAM is a big place. Now how does your CPU is executing a Java program, of course. How is how is your CPU going to identify where your array is stored or your variable is stored? How does it know where it is stored? Well, it knows by its address. So, like for example, I have an address. I live, say, in Bangalore, right? You have an address. Say you live in Uttar Pradesh, Ghaziabad, or maybe you are living in Australia. So everyone is having an address. Similarly, inside the RAM, every variable, every array that you are creating has a memory address. Has a memory address. For instance, let's take the array. This array X is getting stored inside this RAM, and it has an address of 3000. This is the address. Okay. So for variable, it's pretty pretty straightforward. For variable, say I say int int n equals to 10. I say this. So this is getting stored, say for example over here, n equal to 10, and it is having a base address of say 6000. So in case of variables, it is, of course, it's straightforward. However, in case of arrays, technically this is how things are stored. So 3000 first element stored, 3004 second element stored, 3008 third element, and 3012 the final element. But how does this computation is happening? Let's understand the computation on a mathematical level. So this is an integer array. Integer is having 4 bytes in Java. Okay, remember 4 bytes in Java. This is the size. Let's call it S. Let's denote the size by S. So integer arrays are having 4 bytes. Integer element. The size of integer element in Java is 4 bytes. Cool. All right. So your array is starting at 3000. Okay, your array is starting at 3000. This is the location. This is the memory address of your first element inside the array, that is 37. This is the memory address of your first item in the array. So it starts at 3000. So the first address of the array is called the base address. The first address of the array, the first address that is pointing to the first element of the array, right? It is called the base address. So 3000. At 3000, what's the number that is stored? It is 37. So let me tell you this thing. When you are declaring an array inside Java, it does not know. Let me emphasize on this point once again. When you are creating an array in Java, say int x equals to 37, 52, 76, and 81, it doesn't know this, or this. It doesn't know any of the addresses. So now your next question would be, say I want to get this element. How do I get it? I want to get this element. How do I get it? How does my CPU know? Wow, it's in 3008 location. Let's compute. So each of them is 4 byte. Cool. Each of them is 4 bytes. So the first item is stored at memory location 3000. So can we predict where will be the second item stored? Of course we can. So an integer is taking 4 bytes and the memory location is 3000. So 3000 plus 4 gives you 3004. So here your second element will start. Okay, here your second element will start 52. Okay, how do we compute the next address? It's pretty straightforward. Now we have the address of the second element, that is 3004, and every integer is having 4 bytes of data. So 3004 plus 4 gives you 3008. You get the third element. You get the memory address of the third element. Now how do you compute the memory address of the fourth element? Again, simple. Every integer is having 4 bytes of data. 3008 plus 4 gives you 3012. But okay, now how does your computer know? Say for example, you say x2. Now how does your computer know directly what's your address? So it uses this mathematical formula. Okay, so let's say this 2 is our I. Okay, I is the ith element that you want to find out. Whenever you are giving such kind of instructions to your CPU does a basic mathematical computation. What does this computation look like? So let's say that this 2, you want to find out the second element. This is called the I, which element you want to find. So this is 2 equals to base address B. What is the base address? 3000 plus what is the I? What is the ith element you want to find? So it's 2 into S. What is this? S is the size of the data type that is stored in the array. So this is an integer array. Every value, every element is an integer, and integer is having 4 bytes. The size of integer in Java is 4 bytes. So you would simply write 4. So now if you see, it gives you 3000 plus 2 4s are 8. You get 3008, which basically points you to this location, and voila, you get the second element, right? 76. So that's how your computation works. The formula is pretty simple, and that's how your arrays are stored inside the RAM. And just to retake it again, Java doesn't know about all of these addresses. It doesn't know. Whenever you give it, hey, I want x2 or I want x3 or whatever, it uses this basic formula to calculate what is the base address. Java or any kind of programming languages only have the base address, that is the address of the first element of the array. Okay, so with this we can conclude that arrays are contiguous. That means arrays are continuous. So it starts at 3000. We have 4 bytes of data. Now we have arrived at 3004, which is the address of the second element. Cool. Now plus 4 we get 3008. We arrived at the third item. Plus 4 we get 3012. So there is no gap. After 3000 you have 4 bytes of data. Then the next starts at 3004. Okay, so technically if you see technically, let me load this one again. All right, so say you have again x equals to 5 7 okay, 5 7 3 2, something like this, an array like this, and I say that 5 starts at location 3000, and as you know, it is a 4 byte data, so it will take 3000, 3001, 3002, 3003. It will take 4 bytes of data, 1 2 3 4. That's how it stores the data. Okay, what about the next element? Well, the next element will start at 3004, of course. 3004, 3005, 3006, 3007, 3007. And where does the next data start? 3008, 3009, 3010, 3011. It will finish, and this will start from 3012, 13, 14, 15. That's how it looks like. So this is 4 bytes of data, this is 4 bytes of data. That's how the things work. Okay, so similarly, that's how your CPU exactly knows how to calculate the ith address that you're looking for. Okay, this is the mathematical formula. Hope this is clear. Okay, now moving on. Oh, okay, I forgot to emphasize one more thing. So as you can see, the arrays are contiguous, so there is no gap after the first element. So 3000, 3001, like it starts at 3000, it takes 4 bytes of data, 3001, 2, 3. After that there is no gap. The second element directly starts at 3004. There is no gap. It doesn't start at 3010. It doesn't start at 4000. It directly starts at 3004. Similarly, the third element will start at what? 3008. Okay, again after 3007. So second element starts at 3004, 5, 6, 7. It finishes. After that, immediately the third element will start at 3008 location. So arrays are continuous. Okay, there is no gap. So now if we derive derive a definition, a simple definition of array. What is array? So the key three things that you need to focus on is this. Arrays are homogeneous. Every element of the array has to be of the same size and same type. Okay, same size and same type. Arrays are fixed size. So once you declare that x is basically an okay, say x is basically new int of 5, you do this, you have an array of 5 elements. You have an array of 5 elements and you cannot change the size of the array. Very important. You cannot change the size of the array. If it has 5 elements, it will always have 5 elements. If you are declaring it as new int as 10, it will have 10 elements only. In this case, we were having 4 items, right? You cannot make this array bigger. You cannot make this array smaller. Arrays cannot be changed. Like the size of the arrays cannot be changed. Okay. Okay. All right. Contiguous. Okay. That means there is no gap. The storing of elements are in a continuous fashion, like I explained over here. Okay, there is no gap between the first element and the second element inside the RAM. First element finishes at 3003, second element starts at 3004. There is no gap. Similarly, so second element finishes at 3007, third element starts at 3008. There is no gap. So it is continuous. It is contiguous as well. Also, you can include mutable if you want to. I mean that's optional basically. You can include mutable. Arrays are technically mutable, so you can change the individual elements of the array. I can go ahead and say, okay, cut this up and I'll put 100 over here. How do I do that? X2 equals to 100. Immediately this 3 will be gone, 100 will be there. So it is also mutable. So we can say, we can derive the definition like this. An array is a fixed size. I already said it's a fixed size. An array is a fixed size collection of items of the same data type, that's why homogeneous, that are stored at contiguous memory locations. Okay, that means continuous memory locations. Now you can of course add this property as well. An array is a fixed size mutable collection. You can do an array is a fixed size. You can do this as well. Mutable collection of items of the same data type that are stored at contiguous memory locations. You can do that. All right. So that's all. Now another question that rises again. This is optional. If you don't want to understand it, please feel free to skip and move to the next section. However, I'd recommend that you understand this because this confusion lays around for a while and sometimes pops back, and you'll be like, why do programmers use zero based indexing? Okay, so why do we use zero based indexing? Why do we say, and by zero based indexing I basically mean this. Say you are having an array of 625, 330, 421 and 26. Okay, something like this. Okay, so as per the traditional norms, you will always use a zero based indexing. That means you will start the counting from 0 and you will go through 0, 1, 2, 3. Now some people will question, why do we do this? Why not simply use human language? Why don't we just say, hey, this is the first element, this is the second element, and third and fourth? Why don't we do this? I'll tell you why. And that has basically got to do with how computer works, under the hood, and it's about performance. If you use n based indexing, that means 1 based indexing or 2 based indexing. 2 based indexing means you start from 2, then go to 3, 4, 5, something like that, or whatever crazy ideas you are having. If you start n based indexing, what is the problem here? Let's understand. Let's take a demo. Okay, let's say we have the base array of, we have the base address of 6000. Say this element starts at location 6000 inside RAM. Okay, this is the base address. Cool. Of course, this is an integer, okay, for instance. So every integer will be of 4 bytes. Okay, everything is of 4 bytes. Okay, that also cool. 4 bytes. Okay, 4 bytes. All right, cool. This is also done. And say for example, you want to find the 8th element. Now in this example, I obviously haven't used 8th element, of course, but say you want to find 8th element. Okay, how do you compute the 8th element? Using 0 based. This is what we usually do, and in this case we'll use n based or just 1 based. We'll calculate from 1. Okay, let's see what happens. So if we are using 0 based, we will simply calculate it like this. We are trying to check x of 8. Okay, I is 8. We are trying to find the 8th element. Fine. So using 0 based and indexing, we'll simply say b plus, what is b? 6000. This is the base address, plus I into s. I is 8 and size of every single integer is 4. So using this logic, you will simply compute 6000 plus 32. Okay, and you will simply get 6032. You get the answer. Cool. So now now you have the answer. That's amazing. But what about you use 1 based indexing instead of 0 based indexing? What would actually happen? Let's see. If you use the same formula, it will give you a wrong answer actually. Let me show you. Again, if you use the same formula, say you are counting it like this. You are counting it using 1 based. So of course it will start counting from 1, 2, 3, 4, and it will keep going. So of course the I will become 9, right? Because previously it was counting from 0. So 0, 1, 2, 3, 4. If I have an array, just for example, if I have an array, okay, let's take this example. Let's say 10, 20, 30, 40, 50, 60, 70, 80, 90. Say for example, this is our array, right? So using 0 based indexing, we would be counting like this. Okay, this is 0, 1, 2, 3, 4, 5, 6, 7, 8, right? This is how we will be counting. Okay, but using 1 based indexing, of course, we'll be counting like this: 1, 2, 3, 4, 5, 6, 7, 8, and 9. So of course, since we were using 0 based indexing, we were using 8. But for now, when we are using 1 based indexing, we'll be using this instead, of course, 9. So I will become 9, of course. But what is the implication here? Let's use the same formula and let's see what's happening here. So now if I say x of 9, and we're calculating something like this: 6000 plus 9 into 4. That's the only change. 8 becomes 9. What we will get? We will be getting 9 fours. What's 9 fours? 36, right? Yep, that's right. So now if I see, I'm getting 6036, which is wrong. Why? Because first of all, 6036 doesn't it's wrong, because in memory, if it starts from 6000, this is the first element that starts at 6000, then this is the wrong address. We are getting a wrong address. We must get 6032. This is where the actual element is. So we are having an error in the calculation. So to rectify this, to remove this error, we have to modify our formula, and we have to say if you are using n based indexing, if you are using n based indexing, then do this calculation: xi equals to base address plus whatever your um, I you are trying to find out, that I minus n into s. That is the only change that you need to do. So now if I say that assuming that I am still using one based indexing, I will say x9, and again x is 9, right? So I'll be using x9 is equals to base address is still 6000 plus what is I 9 minus n, and we are using one based addressing, so we'll just subtract 1 into 4 is the size. So now if you compute 6000 plus 9 minus 1, 8 into 4, now you will get 6032, and now you get the correct answer. So did you see the problem with n-based approach or n-based indexing style is that every single time you want to compute something, you have to do this extra calculation. What is the extra calculation? This extra calculation. You have to subtract n. If you're using one based indexing, you have to subtract -1. If you're using two based indexing, you have to subtract -2. Okay, so you have to subtract for every single time you are trying to access any element. So that will slow your computer down. That will take more CPU power. Okay, that will take more CPU power. That's gonna cost you, more time. Not it's negligible if you try to do that for a few elements. It's really negligible. When your array really scales up, huge numbers, then you will actually feel the difference. So that's why we generally stick to zero based indexing. Not that there are not any programming language that do not use one based indexing. There are a few languages like Lua and other few which uses one based indexing, and there are also languages which are using two based indexing. But yeah, as a rule of thumb, general programming languages like Java, Python, C, C++, JavaScript, everything generally, all these general languages use zero based indexing. Okay, that is something that you need to keep in mind. All right. Again, hope this is really simple to you. It's just length versus index. What is length? So length is basically when we say how many elements. So length is simply saying how many elements in the array. How many elements in the array. You just count how many elements. 1, 2, 3, 4. So you will say the length is 4. And how do you access length, by the way? To access length, you just need to write inside coding. Inside the code, you need to write whatever your array name is. Say it's arr dot length. That's all you need to do. You will get the length. Okay. What about index? Well, index is the position. And just now I said zero based indexing. So it will start counting from 0, 1, 2, 3. So now, technically speaking, if I just remove. So now if I ask you what is the length, you will calculate like this. Okay, the length is, well, I have first 1 element, 2 element, 3 element, and 4 element. So the length is 4. But now if I ask what's your max index, what is your maximum index, it will always be whatever your length is -1. What is your last index? What is your max index? It's always going to be 1 less than your length. Why? Because it is using zero based indexing. Okay, so okay, that's pretty straightforward, right? So let's move on to the next part. All right, this is something else that I wanted to discuss with you as well. So what are the use cases? What are the real life use cases for arrays? That is something also that we need to understand. So arrays think of arrays as the primary basis for most of the other data structures. So when you are learning data structures and algorithms, you will find a lot of data structures. Like you'll find stacks, you'll find queues, you'll find linked lists, you will find a lot of data structures that are using arrays directly. But Even if I don't go into those things, I'll simply show you where arrays are used. First example is this leaderboard. Say you are playing an online game. Okay, you are playing an online game, right? And there are many players playing with you. Say there are there are five players. Okay, and their scores would be printed. Their scores would be printed. Say this guy is, say, Rahul. Okay, this is Rahul. This is Priya. This is Ravi. This is Kishan. And say this is Rocky. Something like this. Okay. So this is an example of array. This is an example of array. And like I said in the very beginning, arrays can be of any type, but you have to just make sure that the entire array, every element is of the same type. So you also say, for example, these are Rahul is a student object, Priya is a student object, Ravi is a student object. So this is basically a student array. This is a student array. Okay. Now inside this student array, you are having basically 5 students. So this is again an array. This is just a, say you have played a game, you have you are playing this game, and these are the scores. What is this? This is a sorted array. Okay, you are just putting all these students inside the array, and based on their scores or whatever, you are basically sorting it out. So this is an array of student objects, or player objects, whatever you call it. So this is just an array. Now coming to other thing, we have this points table, right? Every single year we have IPL in India. It's a cricket league, of course. So in India we have this IPL, right? Again, after every match, you will see this points table with all the teams mentioned. What is this? This is just an array. Moreover, this is a sorted array. Why I'm saying this? Well, look at this. Okay, look at this. Isn't it sorted? Look at the points or the net run rate. Look at this. This is what? This is descending. This is a descending order sorted array. 18, 15, 15, 14, 12, and 8. Okay. So this is again an array. This is a points table. Which team is having how much points. So these are the real life use cases of arrays. Let me give you some more example to convince you. So this is Spotify. Okay. This is a music streaming service. This is YouTube Music. This is again another music streaming service. So when you are playing a song, based on the song you are playing, using some machine learning algorithms, recommendation systems, it will basically, what it will do, it will keep the next songs that it is planning to play ready. Okay, so this is the current one that is getting played. After this will get played. After this will get played. After this will get played. After this will get. So what it is doing, it is technically using a for loop. Well, not exactly, but just to oversimplify this is exactly using a for loop. For I equals to 0, I goes till the length of the array. Of course, in this case, the length of the array will be kind of infinite, but let's not go there. Let's oversimplify this, and let's understand this, that this is just an array of songs. After this will be played. After this will be played. So everything is having indexes. This is index 0, that is the current one. Then index 2, 3, 4, and so on. Right? That's Spotify you. That's Spotify for you. Right? It will be using these. These are just arrays, and these are just elements. Okay. Again, similarly for YouTube Music as well, the same technology that is getting used. Again, it is a for loop, and this is a list of array. This is a list of array with elements. This is index 1, index 2, index 3, index 4, and there is a for loop that's going on. This is the current music that is getting played. After this will be played, and this will be played, and this will be played. So okay, these are the real life use cases of arrays that's showing up over here. Okay, let's take some more example. This is the most simple one. This is a to-do list. Okay, this is a to-do list. To-do list is basically where you group your tasks, what you need to do throughout the day. In this to-do list, you are seeing multiple tasks that are assigned for today, right? Scheduled for today. So what is this? These are just this again. This is unsorted array, by the way, or you can call it sorted meme, because sorted in ascending order, because today and then tomorrow and then upcoming. So maybe you can say that this is a ascending order sorted array. But anyway, this is nevertheless an array, right? This is the array. So in this array, you have this first element, then you have second element, third element, fourth. So this is a to-do list. This is a to-do list, right? to-do list. To-do list is also an example of array. By the way, when you go into web development or you're doing some sort of web development, you're trying to create a very basic to-do app list, you are going to use kind of an array. You know, that's how you're going to do that. Anyway, last example that I want to show you is your contact list. This is your contact list. Cool. So all your contacts are stored in a database. That's fine. All your contacts, all these contacts are stored in database. But when you are opening the app, these contacts will be displayed inside the app. And what is exactly this? This is a sorted array. Why am I saying sorted? First you will find the names with A, then B, then C, and similarly, you know, this is all sorted. This is all sorted array. This is all sorted array. And you can scroll and you can access things. This is just an example of array. And every array in this case is a contact object. This is a contact array list. Technically, it should be defined like this. Contact is a custom class. Contact is a custom class, and you're defining an array, contact array. This is what it looks like inside the UI. Okay, it should look like this. Again, I'm just oversimplifying this, so maybe not exactly like this, but this is how it looks like. All right, so now we will be using loop and toString method for printing out arrays. So first, understand the loop method. This is the traditional way we use to print arrays. So this is how we do it. We simply run a for loop. Okay, we have this variable I that starts from 0. Of course, this is going to be the first index because we are using 0 based indexing, and it goes till the length of the array. And since I'm using less than, so it will go only like one less than the length of the array. So if my array length is say 5, the loop will go from 0, 1, 2, 3, 4, and it will stop because the condition says I has to be less than 5. So 4 is less than 5. It will stop there, and yeah, that's the loop. So for every single instance of I, for every single iteration of this loop, you will simply just print. You will just simply print arr I. I will keep changing. For the first iteration, I will be 0, then 1, then 2, then 3, then 4, then loop stops. So this is one of the traditional ways that we can use. Let me give you a demo. Okay, it's always better to see it in action, right? So just to give you a demo. All right. So again, let's open JSON. So let's say we have an array. Let's call it int arr. Okay. Int arr equals to 98, 67, 52, 34, and 21. Okay, we have this array. Okay, we have our array created of 5 elements. Now how do we print it? So the first way is using the loop. So we can have a loop for int I equals to 0. I will go till whatever the length. Now of course you can put I less than 5. That can be done because it is having 5 elements, but I mean every time the array length changes and say you are writing this inside a function or something, it would be difficult, you know, it would be difficult to manage this function. So it's always best to say whatever the length of the array. So the array name dot length. This is how we access the length. So I less than array length, and every single time I plus plus. That's all. And inside this loop, all you need to do is to write system.out.println, and you just print it out. So you say arr, inside brackets you say I. So every single time the value of I will change and the items will get printed. Okay, so oops, I just missed a semicolon. Yeah, All right, so for I0, when I is 0, that is the first iteration, you will get this. When I becomes 1, you get this. When I becomes 2, you get this. I becomes 3, you get this. I becomes 4, you get this. And when I becomes 5, you won't get anything, because the condition is I has to be less than the length of the array. The array length is 5, so 4 is the last thing. It has to be less than the 5. So 4 is the last thing. So now if I just run this loop, you can see you are getting this 98, 67, 52, 34, 21. If you want to print this in a single line, all you need to do, just modify this to print, just remove the ln and add a space, rather add a space over here, and you will get everything in a single line. So you see 97, 67, 52, 31, 21. You can do this. Now, I mean, this is still taking 3 lines, right? So if you need to do, we have a shortcut. We have a shortcut for this. And that shortcut is this method. So for arrays, we have we have a library. We have a built-in library for arrays called arrays. Now, of course, in the future video or in the future section, we'll look into all the methods that are available inside arrays. But for now, we are going to use only this method, toString. Okay, we are just going to use this method. So this arrays library is just like math library or string library, a scanner, it's like that. So it's just another library built inside Java. We can use this, and this will just simplify things. So in case, again, let's declare our array. Let me just clear this up. Let me declare the array. Again, this is our array. Cool. Now how do we print using the second approach? So first you need to import the library. So import java.util.arrays. Okay. Once you are done importing this, you can use the function. And you can print on the exact same line. Okay. So directly write system.out.println, and all you need to do is to say arrays dot toString. This is the library that we're using, arrays dot toString, and all you need to put is the array. What is the array name? ARR. Just pass in the array name. Okay, on the same line. And do you see this? It even prints it in a better way. Honestly, this is a better way of printing, and you did this in just a single line. No loop, no nothing, no declaring variable I and doing everything is getting handled by this. Okay, this method .toString can handle it. So these are the two ways that you can print an array. The first way is using loop, the second way using .toString method. I would generally go with this one because of course it is easier, but again, it depends on your preferences. All right, using scanner inside array. So we have used scanner class to take input for a single variable. If we have int x, we did take the user input. The user did give the input from keyboard, and we got the input using scanner. But how do we do this inside an array? See, what I mean here is, let's say we have an array, int arr, new int 5. Okay, new int 5. Of course, this will give me an integer array of 0, 0, 0, 0, 0. Default values. Integer default values is like this. Technically you have an empty array. I mean, although it's technically not empty, it's all zeros. Anyway, so how do you take user input for each one of these? For this, for this, for this, for this, for this. Well, I'll give you a hint. You can pause the video and think about it. Okay, you can think about it. Index of this is 0, this is 1, this is 2, this is 3, this is 4. Now think about it. How can we take input? Stop the video, think about it. Alright, so it's pretty easy. Again, we'll use the same approach that we used while printing. While printing, we used a for loop. We had this variable I, which goes from 0 till the till 1 less than the length of the array. Every single time increments by 1, and every iteration it was printing. We can use the exact same loop. The only difference would be that instead of printing, we would be taking input. That's the only difference. So how can we do it? Simply, you basically write a for loop. You write a for loop. Oh, by the way, first things first, of course you need a scanner object. So create a scanner object. Create a scanner object. Okay. I am just writing pseudocode. Okay, you have the scanner object. Now you write the for loop. I goes from 0 till whatever the array length is. Okay, and every single time you will just take the input from the user. Okay, so you will just write arr I, whatever I is right now, I0, whatever I0, I1, I2, I3, I4 and stop. So anyway, every single time you will just say your scanner object dot next int. Of course, you can print out something over here. You can say enter element I or something like that for the user. Otherwise, the user won't understand, right? So yeah, let's do this. Let's do this. That's all you need to do. Take input. Okay, and then we'll print the array using maybe using toString method, because that's easy, of course. So anyway, going back to our discussion. Okay, all right. Let's define an empty array. Let's initialize actually int arr equals to new int array of 5 elements. Cool. Array of 5 elements. Nice. We have empty array of 5 elements. Cool. Now how do we take user input? Of course you need scanner class. So import java.util.scanner. All right. Now you create the scanner object. Okay. So you say scanner sc equals to new scanner system.in. Okay, we have the scanner object created. Good. Okay, so now just start the loop, take the input, and you're good. That's all you need to do. Okay, so let's start the loop. For int I equals 0, same logic, no change. I less than arr dot length, whatever the length of the array, I plus plus. Now for every single time, all you need to do is to say arr whatever I is equals to. Now you have I have already shown you how you basically replace elements, right? For now everything is 0 0 0 0 0. Now whenever you are saying arr 0 equals to 500, it will become 500 over here. Arr1 equals arr1, that is the next iteration, 200, it will become 200. Arr3 make something, it becomes here arr4, arr5. You got my point. So every single time I iterates, the value of I will change. For every single value, for every single index, we are changing some value. We are basically taking from the user. We'll simply say you can say sc, this is the scanner object that we're using, sc dot next int, and that's it pretty much. So now it is using now it is asking for user prompt, so I'll enter 300. It is asking another prompt, 200, 800, 600 and 100. Okay. It has already taken all the inputs. So again, if you see, it has taken for 5 elements only, because our array was of length 5, and this is our condition. Of course it will take for 5 elements, so 1 2 3 4 5. Cool. All right, so how now just let's just print the array, and we are using the library method toString. So system.out.println arrays.toString, pass in the array name, just print it. Okay, so now you see that we have successfully taken the user input for each of the element of the array. So this is one of the ways that we can take user input using scanner. We can use a loop, and for every single index, we are taking an input from the user. Now of course this is not that intuitive because I'm not asking the user to enter some value. So let me just modify this. Okay, I'll just remove everything. Again, I'll declare this array arr equals to new int 5, just creating an empty array. Okay, and we already have the scanner object, so I'm not creating it once again. We already have the sc scanner object, so let's not create it again. But now what we will do is we'll just write the loop in a better way, and by that I just mean this. Okay, let's do it a little bit later. Let's first print system.out. Do not use print ln, rather use print and say just a escape sequence for a new line. Okay, so just so that every single time it prints in a new line, and the user puts in the same line. So anyway, I just write in enter element I'll just put up here I plus 1. Why I plus 1? Because if I just say I, okay, it will start from 0. It is, of course, it is starting from 0, right? So for the first for the first element, that is this one, it will say enter element 0. Of course you can do that, but if you want it in a human readable form, enter element 1, enter element 2, you just add 1, of course, because that's human language, that's what humans understand, right? So sometimes you have to think about the user as well. So like that, actually I'll do this plus, I'll put a colon over here just to make it look good, you know. All right, now that we are done, oops anyway, a minor glitch, don't worry. So basically it will look like this: enter element 1, the user will enter element 2, the user will enter. Okay, let me just redo it. Okay, I forgot to enter that. Okay, let me just redo it. arr I equals to sc dot next int and close brackets. Okay, so enter element 1 300, enter element 2 200, enter element 3 400, enter element 4 700, enter element 5 400. Okay, so it is there. Just to verify, I'll just print it once again, right? I just print it. This is our array. Okay, so that's how we can get the user input. Again, I am doing I plus 1 because this is why you are getting 1 2 3 4 5. Otherwise you would have gotten 0 1 2 3 4 0 1 2 3 4, that because we were technically using the indexes, right? I'm just adding 1 to make it look good for the user. Okay, enter element 1, enter element 2, like that. All right, so that's how we do it. Let's move to the next section. Linear search. Well, linear search is one of my favorite topics. It is just basically searching items. So for example, you have this array. Just for instance, you have this array. Okay, 26 31 92 61 45, something like this. Now if I tell you, if I just tell you that search for 92, say item 92, I want you to search for this item. So linear search means you will start from the very beginning and you will keep checking, does this value match my item? If yes, you stop. Okay, so so again, it is very clear, very evident from my explanation that you have to use a loop. So you are basically using a loop. Okay, you go for the first element. Does it matches 91 92? No, keep moving. Does it matches 92? No, keep moving. Does it matches 92? Yes. Stop the loop and give the index. What is the index? 0 1 2. So just show the user it is there in index 2. It is there in index 2. Okay, do that. But what if a number is not present in the array? What if a number is not, say 99? I am searching for 99. What will happen? Let's start again. Let me just do that. Yeah, 92, right? 92. Oopsie, wrong color. 92. All right. Now if I start searching again, is it 99? No. You move. Is it 99? No. Is it 99? No. Is this one? No. 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 It never matched. It never matched. The loop finished and it could not find anything that matches 99. So it will give you -1. It will show -1. -1 means it is not there. The item that you are trying to find is not there. Okay, you just display this -1. You just print it out. System.println -1, like that. You can do that. Okay. So what's the logic behind it? Again, think about the logic. So I am iterating through the array. I'm going 0, 1, 2, 3, 4. Again, the logic is clear. I am using a loop. So I'll use a for loop where I starts from 0 and goes till the less than the length of the array. ARR dot length, and I every time will be plus plus. Okay. So of course there is a loop. Now how do we check it? How are we checking it? So every single time we are saying if ARR I is equal to item. Item is the number that you are looking for. If ARR I is matching item, then break. Stop the loop. And print I. Just print I once you are done. Okay. But here's the thing. If you don't find anything, you just print -1. Okay. So technically what you do is inside the loop only you can mention once everything is done and you could not find anything, assign I equals to -1. Something like you can do this and you can print it out, or you can simply say okay, not found, whatever you like. Okay, so let's implement linear search quickly. All right, let's quickly do it. Okay, let me clear the panel quickly. All right, let's have an array. Okay, let's have an array quickly. So we have this array int ARR equals to, let's directly create the array over here. Okay, let's say 45, 23, 56, 79 and 81. Okay, we have these 5 elements over here. We have an array of 5 elements. All right, so now if we want to use linear search, we need only one thing, that is the item. What you are looking for? What is the item that you're looking for? Let's say let's create a variable. Okay, let's create a variable int item. Let's say I am looking for 56 on 56. Let's say I'm looking for 56. Okay, all right, we have this. So we will simply use a for loop for int I equals to 0, I less than ARR dot length I plus plus, and simply we'll say if so every single time it will check. Okay, if ARR I equal item, you simply do break. Okay, you break. All right, or I should just to show you in a better way, just say break. Anyway, the same thing. But all right, after this you say I equal to, okay, not like this, over here put this yep, that's how you do it. Okay, done. So now if I try to search it, okay, what's the value of I right now? Print system.out. print ln. What's the value of I right now? Oh, I is not even, oh sorry, okay, there's a flaw in my code, hold on. Okay, so rather than, what we can do is, every time something like this happens, I'll just use a modification. So just to recover, we have this array and we have this for loop for int I equals to 0, I less than arr dot length I plus plus. Oh, before that, we have our int item, right? And it was 56, so okay, it is there. Along with this, you need another variable for keeping the track of the index. Okay, let's have a variable called index. Okay, index equals to 0. Okay, let's keep it 0. All right, int index equals to 0. Fine. So now if I just check, or maybe simply do this -1. Okay, so this basically I am assuming item not there in array. Okay, I'm assuming that item is not there in array. Okay, so index is basically -1. -1 means item is, I mean, that's how we denote, how programmers denote that the item is not there inside the array or in the data structure. So let's have it. Now let's write a for loop for int I equals to 0, I less than arr dot length I plus plus. We'll just do only one check. If arri, if the index matches the array, right? If the index matches the not the array, if the index matches the item, it will do two things. First thing, it will update the index. As I, whatever the value of the I right now is, and it will break. It will stop the loop. It will break. Okay, that's what it's going to do. All right, let's simply do this. Now if I run this and if I try to check what's the value of index right now, you see 2, which basically means that the item is there on the second index, that is 0, 1, 2. Okay, now just to understand this in a better way, let's take it to the blackboard. Okay, let's understand this algorithm. All right, this is our algorithm. Oops, too big. Just a second. Move this up a little bit. Yes. All right, this is our logic, and this is our array. Let me paste the array as well. Okay, let me paste the array as well. What was the array? This is the array. Okay, let's take a screenshot of the array. And the item that we want to search. Okay, all right, let's paste it over there. Again, quite big. Let me just all right, now let's understand what's happening. Okay, let's start the loop. We'll just dry run it. So for dry running, so we have a few things here. What are the variables that we are using? Array is not a variable, it's just an array. Okay, no problem. We have the item variable, we have the index variable, and of course we have our I, the loop variable. So I, item, and index. Okay, all right. So say, what is the initial value of I? Okay, before that, what is the initial value of item? It's 56. We are searching. This is the item that we are searching. It is 56. What is the initial value of index? It is -1. That means we are assuming item is not there in array. Okay, this is our assumption. If it is there, it will update. If it is there, it will update. Okay, but if it is not there, it will stay -1. Okay, this is our logic right now. Okay, let's start the loop. I0. It will start from 0. It is searching. So the first check is ARR I equal to item? ARR 0, which means this, is it equals to item? Of course no. All right, then of course move on. I becomes 1. All right, is ARR I, which is ARR 1, which is this, equals to the item that I am looking for? It is not. All right, move on. All right, okay, is ARR 2, which is ARR I, which is ARR 2, right? 2 is like this, equals to the item that I'm looking for? Yes, it is. Yes, it is. The moment it is the case, it will update the index with the value of I. So it is basically putting the index where match found. So it will simply update the index. Okay, this is where I found it. This is where I found it. So it will simply do this. It will remove the old value and say, I found the value. It is at index 2. It will do this and it will break. It will stop the loop. It will stop the loop. It will finish the loop. Okay, no more loop. It will stop there only. Okay. So now that this is done and you are printing, say print index, what you will get? You will get 2. That means the item is there. But what happens if the item is not there? If you're looking for an item that does not exist? Okay, let's try that as well. What will happen? Let's clear everything. Let's do the same thing. We have our array. Very good. Let's say we have our index. Okay. Let me first change the item. Okay, the item that we're looking for is maybe 99. 99 is nowhere in this array. Okay, again we have our index. Int index equals to -1, assuming item is not there. Okay, we are first assuming that item is not there. Cool. Let's start the loop. Again, I'll just copy the loop. Yeah, this is the loop. Let's run it. Now let's print the index. System.out.println index. You see -1. That means the value is not there. Why is it happening? Again, you can try run this on your own, and I'll do the same right now. If you want to skip, you can skip. All right, let's understand what's happening in the background. Let's open a new page. Paste. Again, too big. All right, cool. Let's start again. All right, so what are the variables that we're using? We have this item and we have I as the loop variable. We have item, the item that we're looking for, and we have of course the index. Index is -1. Okay, let's write the initial values. Initial value for item is, of course, I'm looking for item 99. Index initial value is -1. We are assuming that item is not there. Okay, and finally we have the loop. Let's start the loop. I0. Okay, let's start the loop. I0. If ARR equal item. If ARR I right now is 0. ARR 0. Is it equal to 99? ARR 0 is what? This. Is it equal to 99? No, it is not. Okay. Okay, let's move on then. Let's move on. ARR 1. I becomes 1. Okay. ARR 1 equal to 99. No, it is not. It is not. Okay. ARR 2. Is it 99? Is it 99? No, it is not. Okay, all right. Increment the value. I becomes 3. Okay. ARR 3. Is it equals to 99? It is not. Increment I 4. ARR 4. Is it equal to 99? ARR 4. Is it equal to? No, it is not. Okay. Increment I 5. Loop will stop. Loop will stop because the condition is it has to be less than the array, less than the length of the array. Length of the array is 1, 2, 3, 4, 5. It will stop at 4. So loop will stop here. So did it find anything? No. No. So of course then it did not update the value of index. Index is still -1. Nothing updated it. So now when you print index, you will get -1, which means the value is not there. Simple. This is linear search. Now the advantage of linear search, linear search is that it will work on unsorted arrays as well as sorted arrays. Now why I am saying this? Well, because there's another technique of sorting, another technique of searching called binary search, which works only on sorted. But linear search will also work on unsorted arrays. Okay, linear search will work on unsorted arrays, sorted arrays, whatever you give. Okay, because the logic is very simple. Okay, you go one by one every element, and keep checking, is it matching your item? If it is matching, stop the loop, give the index. If not, keep going, and finally if none of the items match, you just say -1 and you are done. That's the very basic logic of linear search. So that is again the advantage and the disadvantage. Say you have an array int array equals to new int 10,000 elements. You have an array of 10,000 elements, 0, 0. We basically initialize. Say for example, you have this something like this, and you fill this array. Say you have lots of data inside this array. Say for example, you have inside, after filling this array, after with scanner class or something, you have 300, 200, 600, 700, something like this, and you go on till 10,000 elements. Okay. Now if you use linear search, see, one good thing is that even if you don't sort it, it will work. Linear search will work even if it is not sorted. That is a good thing. But the problem over here is, since this is not sorted, the only way linear search works is by going one by one. So say at say your array is having 10,000 elements, right? Say for example at index 9992 or something like that, at like ARR 9992, you find the match. It is not sorted, so your loop will continue to at least till this point. It will keep going to iterate till 9992. It will go 1 0 1 2 3 4 dot till 9992. So of course it will loop a lot. It will waste a lot of your CPU's energy. Okay, that's something that you need to keep note of. Another thing is that, say the item doesn't even exist, like the item is not even there in the array, so your loop will continue till total 9999, like 0 to, we are using 0 to 0 based indexing, so 0 to ARR 9999, and when it doesn't find anything, it will give you -1. So it will run for this long just to find out the element isn't even there. Again, waste of time. So that is one drawback of linear search, I believe, that it will loop. Even if the item is not there, it will loop till the end of the array. That will take a lot of time and effort, and if you don't find the array, it's a pure waste of time, and for the CPU, that is something that you need to keep track of. So that's why we have another search technique called binary search, but it only works with sorted array. Okay, that we will learn later. Alright, let's jump into arrays and methods. How do we work with arrays and methods? Just to simplify, we will first build linear search method. Okay, we know what linear search is, so we'll simply make a method called linear search it will take two things. We will give it an array and we will give the item. Okay, and it will return what it will return. It will return an integer. Okay, what will be that integer? It will be an index, basically index. Now of course, if index is anything more than or equal to 0, anything more than equal to 0, that means it is there. And if it returns -1, then the item is not there, of course. Okay, simple. Let's create the method. Okay, let's go back to our JSON. Let's create the method. All right, linear search starting up now. Public static. Why? Because let's not associate this to some class. I mean, some object. It's not. We are not doing object-oriented programming at the moment, so let's not attach it to some object, so that we don't have to create another object and then we can call this method. Makes it a bit messy. Anyway, so public static. Now, like I said, it will return integer. So public static int, simple int, because this is the return type. So public static int. What is the name of the method? Linear search. Okay. What are the two things that it will take? It will take the array and it will take the item. Now, very importantly, very importantly, the data type of item that you will be mentioning is of course int, without a doubt, because it's just a single variable, right? But when passing an array to a method, okay, when passing an array to a method, you have to ensure, that you do not write just int. It will give you an error. If you just write int, it will only accept a single variable, a single value. But here you are passing an entire array, so that won't work. So whenever you are passing array to a method, the data type is int bracket square brackets. Basically, you have to mention this. Otherwise, you cannot pass an array to a method. So let's go back to our JSON and let's write it. All right. So like I said, first thing that you're going to pass is the array, and the second thing that you're going to pass is the item. Now you have to write the data types of each, right? For item, you can simply write int. Okay, I am going to pass a parameter, an integer parameter item. That is okay. But the important thing over here is, so when you are passing an array, you cannot simply write, okay, I'm passing an integer array, so I'll just write int and I'm done. No, you are passing an array. So ensure that you let Java know that I will be passing an array. So this is how you do it. You say int square brackets ARR, or whatever you like to say it, call it, no problem. But whenever you are passing an array, you are taking a parameter, which is basically an array. You have to put these square brackets. If it is a string array, you have to say string square brackets. If it is a double array, you have to write double square brackets. But this square brackets is very important when you are taking some sort of array as a parameter. So since I'm passing an integer array, I'll just say int square brackets, whatever name you want to say, and int whatever name you want to say. This is the item that we're looking for anyway. So very simple. Now what we'll do, even this, you know what, this will actually make our life even easier. We don't have to assume anything, we can simply do this rather. So what we'll do is for int I equals 0, I less than whatever the array length is, I plus plus, like exactly like we were doing. If again we put the same condition, if ARRI, that particular element at that index, matches the item that we are looking for, if it is happening, we'll simply actually we can do this in the same line, but for your simplicity I'll just say, if it is happening, we'll simply return I, whatever the value of I is, whatever the value I right now is. And remember this, once function returns something, The function will never like it will never come back again and start. No, once it is written, it is the end of function. It is the end of function. Okay, understand that. So if you find something like that, you do this. Now, otherwise when the loop finishes, all you need to do is return -1. Is return -1. Again, we'll dissect this, So all right, this is our method created. We have linear search method. Now let's try it out. Again, if you see the method signature, it is saying linear search is a method which is expecting one integer array and one integer. Okay, one integer array and one integer. Okay, fine. Let me try it out. So how do we try it out? Let's create an array. Int arr equals to, let's directly create an array. 45, 23, 67, actually 67, 89 and 22. Okay, we have this array created. All right, let's try the linear search method. Let's say, and again let's print it out. Let's directly print it out. System.out.println and just call the method. What is the method name? Linear search. Again, I am not writing the class name and all that stuff because I'm in JShell. But if you're using in Blue Java, you have to write the class name .linear search. Okay, I'll do that in BlueJ for your simplicity, but I'm just running the code right now. Linear, oops, hold on. Linear search. You pass in the array. What is the name of the array? ARR. You pass in the name of the array and you pass in the item that you're looking for. Say I am searching for 89. So I'll just write in 89. So this is the array. This is the item that I'm looking for. And I'm passing this to this function, this method over here. I'll type it. Okay, I'm getting 3 as the output. Is this the correct output? Let's try it out. 0, 1, 2, 3. Wow, it's matching. 89 is in the third index. So we are getting it. But if I try to search something like this, ARR, say 400. Now 400 is not there. What will we get? -1, right? So let's see this in action. What's happening for each of the scenario? Let's take a screenshot again. Let's go back to our board. Paste it. Again, too big. All right. Okay, this will work, no problem. Let's start. Let's see what exactly is happening over here. Okay, cool. We have this method over here. Okay, let's see what's happening. We have this array created. Good. Now we are just calling linear search. We're passing this array, and we are passing 89. Okay, we are passing 89. Okay, it is starting the loop. Simple, it is starting the loop. Now loop starts from 0, goes till less than the length of the array. So the length of the array is 1 2 3 4 5. It will go 0 1 2 3 4 and it will stop. Okay, for 0 it is not matching, for 1 it is not matching, for 2 it is not matching, for 3 it is matching. ARR 3 equal item, yes, it is matching. It will simply return I. What is the value of I right now? 3, right? For, see, of course I is iterating 0 1 2 3. Okay, like that, right? So for 0 it won't match, for 1 it won't match, for 2 it won't match, for 3 it will match. And the moment it matches, why it will match? ARR 3 is basically 89 and I am looking for 89. Of course it will match. Okay, ARR 3 equal item, yes, it is matching. It is returning I. What is the value of I? It is 3. I am returning the value of I. The moment I write this statement return, it will completely ignore the rest of the method. It will completely ignore the rest of the method. Everything will stop. So this is the last line that will execute. Everything else over here will be ignored. So the moment I do this, it will basically return a value. What is the value? 3. It will return a value and it will stop the execution of the function. It will stop the execution of function. That's it, finished, done. Okay. Now let's take the second scenario. What is happening in the second scenario again? Let's erase everything. Let's erase everything. Let's take the second scenario over here. For the second scenario, we are passing the array, we are passing 400. So again, I goes from 0. Is it matching? I0, is it matching? No. I1, is it matching? No. I2, is it matching? No. I3, no. I4, no. So I1, 2, 3, 4, and it will stop. It will stop. Why? Because of this condition, it will stop. Less than the length of the array. Okay, it will stop. And throughout this entire loop, nothing happened. Nothing happened. So simply before ending this method, we are just saying return -1. Okay, we ran the entire whole loop. It kept looping till 4, 0, 1, 2, 3, 4. Nothing matched. At the end, we are saying return -1. So nothing. So the moment you say return -1, it will simply pass -1 over here. You will get -1. You will get -1. Why? Throughout the entire loop, nothing happened. Nothing returned. If something matched, it would have returned over here only, but nothing returned. At the end, you are writing return -1, so you will get -1 over here. Simple. This is how you write methods that can work with arrays. You can pass arrays inside a method. And a method can also return your array. Now we will look into another method. Now we are going to create a method that is basically going to give us an array, okay, of how many elements we want to we want. It will take the input from the user and it will give us the directly the entire array. Okay, so what I mean by this is that we will create a method called fill array, and the only thing that we are going to give is the size. Okay, what is the size of the array that you want? So we are giving it a size of, say, 3. Okay, the moment we do this, it will create a scanner object. It will use a for loop and it will take input for all the elements for the array. So we have 3 elements. So 3 elements, it will take the input from the user. It will take user input, and once it is done, it will return. Here's the most important thing. It will return array. Now, how do you return an array? See, this is the most important part. When you are returning an array, right? What is the return type of the method? It is returning an integer. So you might think I'll just say simply integer, but that's not the case. It is returning not an integer. It is returning an integer array. So you cannot simply say the return type is int. You have to say return type is int square brackets. That's the only difference that you need to know. Okay, now let's create this method quickly. Then we will combine both in BlueJ, and finally we'll get a hang of it. Okay, so let's go back. All right, let's do this. So let's have int whatever, let's have int arr. Now I am not going to create an array over here. Okay, I'm not going to create an array over here. All I am going to do is just call fill array and I'll pass in 5 and it will give me an array of 5 elements. That's what I'm trying to do. But let me first create the array first. The method first. Okay, so I'll just say public static. What is the return type again? It is going to return an integer array, not an integer, an integer array. So return type would be int square brackets. What is the method name? Fill array. It will take the size. Of course, it's going to be an integer. What's the size of the array? It's just an integer, right? So size. Cool. Now what it will do? First thing first, it will create a scanner object. Scanner sc equals to new scanner system.in. It will create the scanner object. It will use a for loop for int I equals 0. I will run till whatever the size less than the size of the array. Now you don't write. Okay, before that, just initialize the array first. Yeah, that is another important step that I missed. Yeah, so write array int arr. This is the array that the method will create basically, and it will initialize. It will basically initialize new int whatever the size is, whatever the size the user gives. Okay, it will create the array first. Now it will basically use the for loop to take the user input for int I equals 0, I less than arr dot length, or you can simply say size. Anyway, both are same right now because user is anyway giving the size and you're creating the array over here. So you can either say I less than size, or you can simply do whatever you are doing and say arr dot length. Any case, that's your choice. It's the same thing. All right, I plus plus. For every single time, it will print out something. System dot out dot print. It will say backslash n, enter element. The same thing that we did while taking the input from the user, right? We are doing the same thing. So enter element I plus 1, so that it outputs in a human readable form, not that 0 1 2 3 4. It will rather in output 1 2 3 4, something like that, and colon space return. Okay, and it will take the input for arri. It will take the user input. How do we take the user input? Sc, we are using this object, sc dot next int. It will take the input from the user, and that's all. It will take the input, and once it is done, taking all the input and everything, it is done, it will simply return the array. It will return the array that it created and it took user inputs, right? It will simply return, and it will work because the return type, here's the important thing over here, the return type is int square brackets. That means it is okay if it is returning an integer array. Okay, so return arr, finish the method created. Let's try it out. Okay, let's see if it is actually working or not. So let's have int maybe x is equals to this. Again, this is the array. Okay, I'm trying to create array, so I can simply call this method fill array, and I want an array of 3 elements maybe. Will it work? Okay, enter element 1. So the moment I say fill array 3 goes inside this size. Okay, it is creating a new scanner object. It is creating an array of size 3, and now it is starting a loop from 0 till 1 less than the array length, and for every single time it is printing enter element whatever the value of I is. 0 plus 1, it will give you 1, 1 plus 1, it will give you 2, and then 2 plus 1 it will give you 3. Okay, and it is taking the user input. Say I am giving 300, 100, and 400. Okay, so now if I print x, anyway you can see value of x right now. This value, the array that we created, now it is having 3 elements, 300, 100, 400. If I try to print this out, system dot out dot println, and I use arrays dot to string x, you see we are getting these 3 elements. So similarly, now we don't have to every single time, we don't need to create we don't need to create an array by ourselves or create the entire scanner object and everything in the same thing. It will make it look very untidy. So again, let's try it once again. Okay, if I try this out once again, arr, let's do it int x equals to int x equals to fill array, maybe 10. Let's do this. So it will take 10 inputs from the user. this is the array. Again, let's print it out. This is the array. So it has taken 10 elements. So isn't it very easy? Now we don't have to create everything and take the user input using the for loop every single time we are creating an array, right? So we are using methods to reduce our number of lines of code. So now let's open BlueJ, and for one final time, let's see what exactly is happening. Let's open BlueJ. All right. Okay. Do this thing once again. Again, I'll modify a few things over here. Entry point student. Okay, let me just remove this thing. Okay. All right. Save this. Compile this. All good. This one, just delete this. Okay. Delete the student class. All right. All right. Let's have. This is the entry point. We don't do a lot of stuff in entry point. Okay. The main thing where we create our methods is a separate file. So write a new class. Let's call it what? Let's call it demo methods or whatever, like test or something. You can name it whatever you want to, but let's call it test methods or test methods. Okay, something like this. This is our class. We create our new class. This is our class. Let's close this one out quickly. Open this. Let's start coding. Okay. Don't need this. All right. Inside this, let's start creating two methods. So what are the two methods that we are using? We will create two methods. Okay. The first method is taking the input. That is fill arrays method. So we will simply say public static. We are taking the we are basically taking user input, and this method is returning us an array, right? Public static int. Okay. This is the same method that we just used basically a few moments ago. It is the fill array method. So public static int square brackets fill array. It is taking int size. What is the size of the array? And it is simply doing, I'll copy paste just to save time. Can I copy paste, by the way? I'll try to. Oops. Okay, I need to remove these things. Just a second. All right, this looks good. Just a little bit of indentation over there. Not working, is it? Okay, of course I did not import, so let me just do it. Yeah, scanner is imported now. This looks good. It will return the ARR. Fine. Okay, we have our first method. This is our what? Fill array method. It will basically give us an array. Then we have the linear search method. It is again public static. Again, this linear search method will return an integer, right? Linear search. It will take two things. It will take an array, so you have to mention int square brackets ARR. It will take the array, so whenever it is an array you have to mention square brackets. And so what's the difference? It is giving an array, that's why int square brackets. It is taking an array, that's why int square brackets inside the parameter list. And it is also going to take an item that you are looking for. Again, I'm trying to copy paste. Let's see if I can find the function method. Yep, I did. Let me copy paste this as well. Paste, paste, paste. Right. All right. And we are done. We have two methods. One is fill array, one is linear search. Okay. So are we missing any methods? No, not over here. All right, cool. Let's compile this. Oh yeah, good. Let me do this and go back to our entry point. In our entry point, we just need to do a few things. First, we need to import the array method because we need to array class array library because we need to print things, right? So I'll just import java.util.arrays. Okay, just do this. Now it's pretty simple from here. It's pretty simple from here. You create an array, int arr equals to, or x, let's call it x equals to, you first create the array. How do you create the array? You call it again. You are in the same package. Okay, you are in the default package, so you don't need to import your test methods class. Again, if you have forgotten, try checking out the packages video. Okay, as long as you are in the same package, you don't need to import your other classes. It is already there. Your Java can also see, your entry point can basically see test methods, so you can directly write it over here. You can simply say test methods dot fill array, whatever the size you are trying to get. You can say 5 array of 5 elements. After this, you will try to find something. Say you are trying to find maybe 10. Okay, you will try to find 10. So you will simply say system.out.println, and you will simply say, okay, let's first print the array. Let's first print the array first. Okay, so to print the array, arrays dot to string, you print the array. Done printing the array. Now you search the item that you want to search. Okay, so you will simply say system.out.println, and you will say test methods dot linear search, and you will pass in the array first. What was the name of the array? It was x. Okay, so you pass in the name x and the item that you are looking for. Maybe you are looking for 78. Let's see if you get it or not. Okay, let's save this. Am I missing some? Oh, I haven't. Now close the bracket. Right, now I'm all good. All right, let's compile this. So it will be calling the fill array method. Fill array method will take all the user input, blah blah blah. It will return the array. Now x is the array. Now again, it will call the linear search method. Linear search method will search for 78 inside the array. Okay, let's compile this. Again, you can, if you want to, you can automate this as well. Let's actually, let's automate this. In fact, let's automate this inside linear search only, or maybe we can automate this inside here as well. Whatever you like. I'd rather prefer doing it over here. Or okay, let's do this. Let's not complicate it. We can use scanner class to get this thing. Okay, what item are you exactly looking for? The user enters the item, you get the item, you search the item. Okay, let's compile this. Let's run this. Okay, run. Okay, enter element 1, u element 67, element 2 45, element 78, 34, element 5 89. Okay, so again you can see 67, 45, 78, 34 and 89. It was searching for this element 78. So where did it found? 0 1 2. It found it over here. Okay, here you go, here you go. It found it. If it could not find, if it did not find it, then the answer would have been -1. Okay, so let's make it a little bit more interactive. So in this main entry point, you will ask the user for what is the size they are looking for, this size, and what is the item they are looking for. So it will make things a little bit more dynamic, and then we'll finish this video. Okay, import java.util.scanner. We're importing scanner here as well, and we'll create the scanner object quickly. Scanner sc equals to new scanner system.in. Okay, we created the scanner object. Now let's ask the user for the size. Okay, that's the best thing. Int size equals to sc dot next int, and of course before that prompt the user system dot out dot print. Do not use ln, just say session enter array size. Okay, you prompt the user. After this, user will enter the size. After that, it will create the array with the size that user has provided. It will use the size variable that the user has provided. Now once the array is done, it will print out the array. Now it will search, it will ask, enter the item you want to search. Let me just copy paste things. Okay, and paste over here. Okay, it will is going to be item. Okay, item, enter item to search, enter item to search. Okay, it will enter the item, and once it enters the item, we just pass the item. We just pass the item that this is the item, search for item. Okay, you can do that. Okay, let's compile this. Let's see, compile. Okay, this has compiled. Let's see how our program works. Entry point, void main point. All right, actually, should I just close control C? It won't get close. Options, no, it won't get close. Clear this actually. Yeah, so say I am entering. Okay, it was asking the size of the array. Say I want array size of 3. Okay, element 1 is 34, element 2 is 56, element 3 is 10. Enter the, okay, this is the array. Now it is asking enter item that you want to search. Say I want to search for 56. So it is in index 1, that is 0 1. Okay, it is in index 1, so it is searching fine. Okay, let me clear it again and let me rerun this. Rerun this. Enter array size. Let's say I'm searching for 5 elements. Sorry, I need array size of 5 elements. 45, 23, 89, 56, 12. Now this is our array. 45, 23, 89, 56, 12. Enter item that you want to search. I am searching for maybe 13. 13 is not even there, so I'm getting -1. But again, this is a bit not intuitive, right? It is not bit intuitive. So what we can do is write a few things over here as well. I mean, we can simply use a ternary operator. Okay, so we'll do is, or you can use if else, that's up to you, but I'm going to use a ternary operator. So if this is giving, I'll just write a condition over. If this is giving okay, if this is giving maybe like this, okay, and then you have to use a variable actually to store things. Okay, let's not complicate things over here. I don't really want to complicate things. Anyway, this is how you do it. If you really want to check that, okay, if it is -1 or something, that then you can add your stuff, right? Then you can add that, okay, what exactly I'm getting, and I like that. Okay, so to make it more intuitive, what you can do is this. You can have x, actually, or we can, actually we can do it. Let me try it out. Yep, maybe we can do it actually. Let me see. Let's use a ternary operator here. If it is giving you anything less than 0, okay, if it is giving you anything less than 0, then you say not found. If it is not giving you 0, by the way, if it is not giving you 0, then you simply call it again. This might work, but let me check. Let me compile this. It should work technically. Compiled. Let me quickly test it out. Again, this is actually wasting the CPUs. Like, it is again calling the method, so it is again wasting. You should actually store it, not every single time. If you do it in a shortcut, it will work, so let me try it. I have an array of 3 elements, 10, 20, 30, and I'm looking for 20. It is giving me 1. Okay, but actually we can make it a bit more efficient. We can do that actually. Let me do it. Let me store it somewhere. First, let me store it somewhere. So I can say int search result equals to, now I'll call the method. Okay, now I can call the method. Okay, just to make it more convenient to understand things, I'll have this integer variable, and I will store the search result inside this. So I'll just call test methods dot linear search. I'll pass in the array, I'll pass in the item that I want to search, and it will of course return me some integer. Now, quick thing is this. I can simply say system.out.println. We can use a ternary operator. Okay, search result less than 0, then of course it is not there. Okay, so you simply write not found. Good. However, if that is not the case, you simply print the search result. Simply print the, or you should make it a bit more complex. You should do this something like this. Should do this something like this. You can simply say uh, item found at index, add a space, now add search result. Item found at in the index search result. This looks good. Let's compile this. All right. So what I'm essentially is doing is I'm using ternary. Yeah, of course you can use if else. It's up to you. So I'm just checking search result less than 0. That of course if it is -1, or you can rather say if it is equals to -1. Even this works. Okay, whatever you say. Okay, if it is equal to -1, then it is not found. Otherwise, you can simply say item found at index. It will simply print out search result, whatever the search result is, maybe 2, 3, 4, whatever. You can compile this. Let's try it out quickly. Let's see if this is working. Run the program. Okay, enter array size. Let's enter 5. Let's enter 5. Okay, element 1 is 67, element 2 is 23, element 3 is 45, element 4 is 12, and element 5 is 89. Okay, we have the array. Now it is asking for enter item to search. Enter whatever item you want to search. So say I am trying to search 45. Okay, 45 I am trying to search. I'm taking 45. Enter it. Okay, you can see since it found 45, it will say item found at index 2. Index 2, 0, 1, 2, it found the item. Okay, so it will work. If it finds -1, it will say not found. So that way you can make this more interactive. That is one way to do it. So just take another look inside the program. Just have a look. This is how you do it. Again, if you're confused about the ternary operator part, you should definitely try checking the if else orange videos that I made. It contains a lot of practice stuff. There you will find a lot of exercise on ternary operator. But this is what it is essentially doing. If it is equal to -1, it will say not found. And if it is not the case, then it will say item found at index, whatever the search result is, will print it out inside print, of course. All right, so that is all for arrays. See you in the next video.